Well, here we go. Lesson 9.3, altitude and hypotenuse theorems. So this is all about taking a right triangle, flipping it onto its hypotenuse with the 90 degrees sticking up, and then drawing an altitude down from there. Your shapes might be rotated in the chapter, but in the unit, but just flip them this way so you can orientate them to your notes. All right. First thing to note is there's three similar triangles that are formed by doing this. Hopefully you can see that each of these, if this is an altitude, each of these three right triangles are similar. First of all, they all got right angles. And then you can see that this one has angle A, which is similar to that one. And angle B is similar to that one, which is also similar to that one. So all three of them are similar to each other because that's similar to that and that's similar to that. Therefore, all three of them are similar. Because of that, we can set up corresponding sides of similar triangles. So there's two ways to go about doing the problem. You can set up proportions like we did in chapter 8. And for example, if you take this short side versus the medium side on any triangle, that will equal the short side versus the medium side. Or if you have the hypotenuse divided by the short side, then you have the hypotenuse divided by the short side with any of those. The other way is to memorize three new shortcuts. All right, to those. So I'm going to explain it both ways as I do the problems. To do that, I have relabeled it, this triangle, using A, B, and C, and D and E. Okay. So if you want to draw another one with those labeled sides, that would be good. All right, pause the video here to do that before you progress. So the shortcut, well, let's first of all go through setting up a proportion. Notice B, if I think about this triangle here, B is the long leg divided by the short leg. And then if I go to this triangle here, I have long leg, short leg. So I could say B is to D as E is to B. Notice how we end up with B's in my kitty corners, so to speak. That means if I cross multiply, and here's our first shortcut, B squared will equal D times E. Now notice how that looks back in the diagram. B squared is equal to D times E. There's a kind of symmetry there that's nice to see in the original diagram. Similarly, if I take the hypotenuse divided by the short side, again, I'm looking at the small triangle, yeah, compared to, now if I look at the big triangle, I have the hypotenuse divided by the short side. So for example, I would have D plus E over A. So I have A squared is equal to D times D plus E. Again, looking back at the triangle, we have A squared is equal to D times D plus E. Similarly, we can set up side C is to E. So now I'm looking at the medium triangle and the hypotenuse and the long leg. And then if I compare that to the hypotenuse and long leg of the big triangle. So again, I would have D plus E is to C, which means C squared is equal to D times D plus E. All right? So the other thing that you'll remember is this from chapter 7, I believe it was called a geometric mean. Yes? So A and B and C are geometric means. All right? So that's another way to remember from a previous concept Sorry about that. Geometric mean is B, is A, is C. All right, here we go, trying it out in an example. I've got 2 examples for you to copy in your notes, and then you can start working on the homework. So here we see that we've got our legs. Again, you can set this up as the medium with the, no, I was right. The short is to the medium, short is to the medium. So 3 is to x, as x is to 9. Or you could just say x is the geometric mean between 3 and 9. Either one will get you to the same spot, because notice if you cross multiply, you end up with these same equations. So x squared is 27. We take a square root of 27. We ignore the negative, but make sure you simplify. So there we have our value, 3 root 3. All right, one more. Again, if we take the short triangle and you say small triangle, and look at the hypotenuse and the short leg, and then we have the hypotenuse and the short leg. Okay, so x plus 21 over 10. Notice how you'll always have those 2 matching up in the diagonal. So 10 squared is the geometric mean between x and x plus 21. So we get x squared plus 21x equals 100. Good old quadratic equations. And now you're trying to think of what number is multiplies to give me 100, but subtracts to give me 21. Okay? And, well, 10 times 10, but if you make one of them negative, that would give you 0 if you add them up, right? But if I take 20 times 5, that gives me 15 if one of them is negative and I add them. And that's pretty close. And let's see, 25 times 4. There it is. Okay, so I think I need the 25 to be positive, though not negative, and the 4 to be negative. All right, so x is equal to negative 25, or x is equal to 4. And we're going to take 4 as my answer, because it's positive. Keep in mind, always go back and answer the question that they ask. All right, I'm not going to bother with the proof, so that's it. Good luck in your homework as you work on these altitude drawn into, I should say, the hypotenuse.